Hey, so welcome to the next video. Here we're going into our next main topic, which is divisibility factors and number properties. Now, this topic is something that I think people have a lot of trouble with on the GMAT, but I'm going to make the bold claim that I think these questions are probably some of the easiest once you get used to what there is that you can and can't do and what the rules are. So there's a lot of stuff in here in terms of rules that you probably just, if you haven't studied divisibility, etc., it's not something you would have covered in school particularly. So this video is mainly just to show the rules and give you, again, the toolbox. And then the next video will be covering a bunch of questions and showing how to apply them. So the first thing I want to say is when you have a question that's clearly in some way about divisibility, factors, multiples, the idea of if something's an integer or anything like that, then the first thing you want to do before you even worry about solving the question is just any number that you see, start factorizing it into primes. So for example, what I mean by that is, and make sure you know how to write prime factorization out. So for example, if I take the number 72, or let's say there was a question that said 72n equals m cubed or something like that. I don't want to actually talk about what we're going to do to solve it, but all I'm saying is, let's say you've got a question like this. The first thing you want to do is just immediately say, well, 72, what is that? Well, that's 2 times 36, which is 2 times 6 squared. In other words, 2 times 2 squared times 3 squared. So in other words, that 72 can be rewritten as 2 cubed times 3 squared. So that's just the first thing you always want to do. And if you're not familiar with prime factorization or don't feel comfortable with it, make sure you get very comfortable with that, look it up, and make sure you learn how to do it. It's very, very simple. And so that's the first rule to always keep in mind. Regardless of whether you know why you're doing that, just make sure you do it. The next thing, once you've factorized things into primes, just make sure you know about highest common factor and lowest common multiple. Effectively, highest common factor, if you've got a number A, let's say this is, now let's do a real example that's probably easier. Let's say we have 24, which is 2 cubed times 3, and 30, let's say 36, which is, what's that going to be? That's going to be 2 squared times 3 squared. So to do, just quickly, to do highest common factor, you just want to have a look at any factors that are repeated in both numbers. So for example, we've got 2 squared in both numbers and we have a 3 in both numbers. So the highest common factor will be 12. And then the lowest common multiple is sort of the inverse of that. It's take any number that appears, but don't repeat it. So what I mean by that is, if we start with the first number, 24, we've got a 2 cubed and a 3. And then we've already used up all the 2's because we've already got 3 sets of 2. So we don't need any of the 2 squared from 36. But we haven't got our second 3 for 36. So we can do times 3 again, which will give us 8 times 9, which in other words is 72. So obviously not an in-depth explanation on HCF and LCM, just make sure you're familiar with what they are. And again, very easy to find out how to do it if it's not something you're particularly familiar with. These guides aren't intended to sort of go in detail into how to do these sort of simple areas. It's sort of more to point you towards what you need to know, because it's very easy to find those things elsewhere and I don't want to waste everyone's time. Okay. So then the next little trick, you'll often get questions asking you about the number of factors of a number, or if they tell you a number has a certain number of factors. Why is that useful? Well, if we have a number A, which once we express it in prime factorization is P1, so prime 1 to the X, prime 2 to the Y, prime 3 to the Z. It's a very, very simple and quick way to figure out the number of factors. And it's literally just the number of factors will be X plus 1 times Y plus 1 times Z plus 1. So just to give you a more concrete example, well, let's pick a number at random. Let's just take 100. How many factors does that have? Well, that's 2 times 50, which is 2 times 2 times 25. In other words, 2 squared times 5 squared. So how many factors does that have? Well, 2 plus 1 times 2 plus 1. So in other words, 9. And that's just an important trick you need to know. So the first of the rules that may or may not be obvious to you. The next sort of weird rule that you need to learn and trick is to do with factorials. So there's actually a few things in here. First of all, n factorial is divisible by all primes less than, well, all primes less than or equal to n. And that should be pretty obvious, because if you write out n factorial, every prime less than or equal to n will be included in that number. So of course it's divisible by that. But then the important sort of corollary to that is that n factorial plus 1 has the lowest prime factor greater than n. And that's because every single prime factor will have a remainder of 1 at below n. So just for example, 50 factorial plus 1 in prime factorization will have no primes less than or equal to 50. So the first prime number that divides it is bigger than 50. That's all you can really say. You can't say much more about it. So that's one important thing. And then the other trick is for trailing zeros, or alternatively sort of the same thing, asking how many times does a certain number show up in the factorial. For example, let's give 2 examples. How many trailing zeros does 100 factorial have? Well, how do you get a trailing zero? You need, in its prime factorization, you need 100 factorial to have a 2 and a 5, because that's how you get a trailing zero, 10, obviously. And so in the prime factorization of 100, we'll have some amount of 2s and some amount of 5s. Now, given the method I'm about to show you, it should sort of be intuitive that there's going to be more 2s than 5s. So we're going to be limited by the number of we're going to be limited by the number of 5s we have. And so the important question is, how do we identify how many 5s there are in 100 factorial? And there's actually a sort of neat little trick that's very easy to apply, and make sure you learn this. What you do is you take the number 100, you divide it by the number we're talking about. And when we do this trick, it has to be a prime number we're dividing by. So I'll talk a bit more about that in the next thing there. But so we divide it by 5, and that gives us 20. And then you take that number 20 and divide that by the same thing again, and it gives us 4. And then you try and do it again, and you just ignore the you ignore any remainders. So actually, let's ask how many trailing zeros does 101 factorial have, just to prove the point. So 101 divided by 5 is going to be 20 when you're ignoring the remainders. And then 20 divided by 5 is 4, and then 4 divided by 5, if you ignore the remainders, is 0. And so then you're done. So the answer is you just add up the numbers. So 20 plus 4 equals 24, and that is actually the answer. So the sort of other use in which this comes up is what is the largest n such that, let's say, 50 factorial over, let's do 4 to the n, is an integer. So talking about what I said before, we have to do this trick dividing by a prime number. So what we have to do first of all is rewrite this as 50 factorial over 2 to the 2n. And so the question is, how many 2s are in 50 factorial? So let's do the same thing again. 50 divided by 2 equals 25. 25 divided by 2 equals 12, if we ignore the remainder. 12 divided by 2 equals 6. 6 divided by 2 equals 3. 3 divided by 2 equals 1. And 1 divided by 2 equals 0. And so then we add them all up, and we get 37, 43, 46, 47 is the answer. So there are 47 2s in in 50 factorial. And so what's the largest n such that we don't, such that 2 to the 2n is not greater than 47? Well, I suppose n would be 23, because if it was 24, then that would obviously be double that, and that's 48. So that's sort of, and you can see why with this topic, there's just these tricks that you need to know. And if you don't know them, good luck doing these questions. So don't worry if you found questions before this hard, because you're not supposed to be able to figure this stuff out. It's just, I would just view it as a syllabus. Okay, so then we're going to move on to when there's questions that are sort of, they look a bit like simultaneous equations, except everything involved is an integer. And these sort of two topics are going to go together. Effectively, I'm just going to talk about how you use the idea that things are integers to your advantage. So let's actually cover 6 first. If I have a number, if I have some quotient, so let's say a bunch of primes on the top. No, in fact, let's not use letters. Let's just use numbers. 2 squared times 3 squared times m over 2 times 3 times 7 squared. Well, if I'm told this is equal to an integer, then the rule for an integer is that effectively you need everything on the bottom to cancel out. And that's why prime factorization is so helpful, because the only way primes cancel out is if you have exactly those primes on the top. And so in order to use the fact that it's an integer to our advantage, what does this tell us? Well, if you just sort of cancel as far as you can, then we can rewrite this as, well, we'll still have a 2 on top, and get rid of that. We'll still have a 3 on top and get rid of that. But that's 7 squared. Well, the only place that 7 squared could be divided out of is m. And since we know it's an integer, we know that must occur. And so we must be able to say m is divisible by 7 squared. And so whenever you're talking about things being integers, just always think about rearranging to get one of them and find out what that tells you it must be divisible by. So for example, let's say that 3x plus 7y equals 100, where x and y are integers. Well, what does that tell us? That tells us that 3x equals, and using the rule here, we're going to factorize this fully. So 3x equals 100, which is 2 squared times 5 squared, minus 7y. In fact, no, this is not a particularly good example. So let's make a better example. Let's say equals 49. Okay, so equals 7 squared minus 7y. And so therefore, we can say that x is equal to 7 lots of 7 minus y divided by 3. And we know x and y are integers. And so that 3 must cancel somewhere. And it definitely doesn't cancel with the 7. So what does that actually tell us? Well, it immediately tells us that 7 minus y must be divisible by 3. Or in other words, 7 minus, and assuming x and y are positive integers, then we immediately know that all we've got for y can either equal 1, in which case, because then we've got a 6, or y could equal 4. And so, and then that will tell us what x is. And we could have done this in reverse. It's just sort of, i.e. rearrange for y. It's just sort of helpful to know what you're aiming to do and why these, that's sort of the way to solve integer problems. Okay, now perfect squares and cubes. These are actually gift questions when they come up. If you have a number that's squared, all you need to know is that in prime factorization form, it must be, every single number must have an even power, every prime. And cubed, every number must be a multiple of 3. So to show you why that's so helpful, let's say, returning to our earlier example, 72x n equals m cubed, what is the smallest value of n? Well, just following the rules, we prime factorize at first without knowing why necessarily, just because that's how it's done. And that's going to be, I believe, 2 cubed times 3 squared times n must be equal to m cubed. Okay. And then we notice this cubed. And so on the right, whatever prime factors show up must be multiples of 3, which means on the left, we must also have everything being a multiple of 3. And so what's the answer in this case? Well, we've already got 2 being a multiple of 3, so that's not a problem. But 3, we've only got 3 squared. So we must be able to get another multiple of 3 somewhere. And so in this case, the only place it can be is n. And so, but that's also all we need. So in this case, if we have n equals 3, then the left becomes 2 cubed times 3 cubed. And so that's the smallest value of n. And just to show it works, we get n cubed equals 2 cubed times 3 cubed, which is 216, which is equal to, I believe, 6 cubed. So that's how to deal with perfect squares and cubes. And then just another mention of this difference of 2 squares thing. Again, you'll see this kind of thing a lot. 5 to the 16 minus 3 to the 16 over, something like that, must be divisible by question mark. And so effectively, all you want to do for these kind of questions is just difference of 2 squares over and over again. So this is 5 to the 8 plus 3 to the 8 times 5 to the 8 minus 3 to the 8. But we can keep doing that. So that'd be 5 to the 4 plus 3 to the 4 times 5 to the 4 minus 3 to the 4. And so you hopefully get where I'm going with this. 5 plus 3, 5 minus 3. Okay, and now why is that helpful? Well, now this is a lot easier to work with. I don't really care about this thing because that's too big to sort of think about, but what are these numbers? Well, that's 2, that's an 8. This one is 25 plus 9, so 34. And then, these ones, if we really need to work out, we can. But the point being that now we've clearly got some things that it must be divisible by. And so that's going to really be all that's needed to be done in the question. And so then the next rule we're getting onto is what rules we have to follow if we know certain numbers are divisible by something. What happens if we multiply those numbers together or divide or something like that? So multiplying is very easy. If A is divisible by 6 and B is divisible by, let's say, 8, then AB must be divisible by both of those. In other words, 48. Both those multiplied together, and that's actually very helpful. But going back the other way is slightly more tricky. If we know that AB is divisible by 48, what does that tell us about the divisibility of A and B? Well, it doesn't really tell us much, as in we know that together they're divisible by 48, and so together, the split between them, they must have a factor of let's say, well, 48 is 2 to the 4 times 3. So there must be 4 2s split between A and B and a 3 split between A and B, but we don't know exactly how they're split together. And so just divisibility, not necessarily that easy to work with. So for example, if we know A is divisible by 3, then what can we say about A over 3? Well, not much. However, if we know A is divisible by 3, but not divisible by 9, well, then we know there's only one 3 in A, because if it had 3 squared, it would be divisible by 9. And so in that case, A over 3 will not be divisible by 3. So divisibility rules, not as easy as multiplication rules, but you can sort of learn a bit from it. You just, again, have to sort of start prime factorizing as soon as you can. Then point number 10 is actually nice and easy. Adding and subtracting just in general ruins divisibility. You saw this question where they asked 5 to 16 minus 3 6 to the 16 must be divisible by question mark. I can say almost nothing because I've got two numbers added or subtracted from each other. And so the only way I was able to actually make any progress was by eventually at the end, what did I do? I got it into 5 numbers multiplied together, whatever this is. And obviously multiplication is nice and easy to deal with. So effectively, if you have the number a and it's divisible by something, then what's a plus b divisible by? Well, unless you can factor something out, who knows? So just be very careful about making rules. If you want to make a claim about some added numbers together being divisible, make sure you sort of write down the algebra and can factorize it out. For example, if a is divisible by 5, b is divisible by 10, what is a plus b definitely divisible by? Well, we'll sort of talk about this in a second, but we can say that a is equal to 5 lots of some number, and b is equal to 10 lots of some number. So a plus b is equal to 5q plus 10p, in which case we can say for sure that a plus b is divisible by 5, but we can't say much else past that. Okay, consecutive integers. These are actually quite important. There's a few rules here because they sneak them into the GMAT very often. For example, this is obviously a list of consecutive integers, but if they give you something like this, well, if you factorize that, that's x squared minus 1, which is x minus 1, x plus 1. And if you look at that, those are actually 3 consecutive integers multiplied together as well. So just be on the lookout for consecutive integers in the GMAT. They like to sneak them in quite a lot. And why are they important? Well, n consecutive integers is multiplied together. That's very important. Multiplied together is always divisible by n factorial. Now that's a very useful fact, because what does that tell us? This case here, n plus 1, n plus 2, well, that must be divisible by 3 factorial, in other words, 6. Then you get a similar rule for consecutive even integers. Consecutive even integers, so, you know, n plus 2, n plus 4, is always divisible by 2 to the n factorial. Now that's actually quite a powerful result. So 3 consecutive integers must be divisible by 3 consecutive even integers must be divisible by 2 to the 3 times 3 factorial. In other words, divisible by 8 times 6, so 48, which is maybe not so obvious, but obviously very helpful to know, because if it's divisible by 48, what else can we say it's divisible by? Well, any factor of 48 as well. Okay, the next thing is if you've got a question involving remainders, so let's say we know that some number n divided by 5, so n when divided by 5 has remainder 3, we know we can write, the way to write n is 5 of some number plus 3, and when divided by 7 has remainder 1, so n equals 7 of some other number, make sure you use different numbers, plus 1. And then usually in the GMAT, if we know n is, let's say, between, so 10 is less than n is less than 60, I don't know if this will work out, let's just see if it does, then usually it's just a set of cases to run through. So what could n be? Well, we know it's a multiple of 5 plus 3, and it's greater than 10. So in other words, n can only be 13, 18, 23, 28, 33, etc. But it's also a multiple of 7 plus 1. So it could be 15, 22, 29, 36, 43, and I believe we would have got 43 here as well. And so all of a sudden, we know what n is. So that's how to deal with sort of when they talk about remainders. And just in general, even when they're not talking about remainders, if you know that n is divided by 5, it can just be very helpful to say, if n is divisible by 5, just write it out as 5q, and then just refer to it as 5q later on, because then it's very easy to factorize and stuff like that. Another thing, just a quick thing to mention, they ask you what is the remainder when 3 to the 243 is divided by 7, for example. Nothing clever to do here. Just start listing out the powers of 3 and just find out what the remainder is when you divide it by 7. So that's obviously remainder 3, 2, 6, and then stretching me a bit, 4. Okay, clearly picked a bad example. That's so by 10, 5. Wow. Okay, so we're working all the way through. The point being that there will be a pattern. If I'd picked a better example, it might have said 3, 2, 3, 2. In which case, you can just sort of, figure out what the remainder will be when you get all the way up to 243. Okay. Now, very important section for which I would like to claim I have a method that I haven't seen elsewhere. There are some questions on the GMAT about odd and even integers, which can be extremely annoying. So if you are told a number p is odd, then you want to write it as, it can be written in this form. And if it's even, it can be written in that form. So that's the sort of basics of odd and evens. And it can be useful, but that's not really what I want to discuss with odd and evens. What's more likely in the GMAT is you're told something like this: xy plus xz is even. Let's say x plus y is odd. Something like, is z definitely even or odd, or something like that, right? And this can actually get very annoying if you don't know what you're doing in terms of writing this out. So I like a very quick time saver, which is if you just write all odd numbers as 1 and all even numbers as 0, and just sort of every time you go above that amount, so if you get up to 3, just reduce it back down to 1. And if you go up to 2, reduce that back down to 0. And just write this out, and you'll see that actually, effectively, whatever your result you get tells you about what the numbers are. So I'll do this example because what I just said probably made very little sense. So what do we know? X, y plus x, z equals even. So in other words, equals 0. So what can we say about that? Well, we've got x, y plus z equals 0. And so either x equals 0 or y plus z equals 0. So that's what that first thing tells us. And then we have x plus y equals odd. So x plus y equals 1. And so either let's throw in another thing just because we haven't got enough information. And we also know x is odd, let's just say. Okay, so either x plus y, so either x equals 1 or y equals 1. So either x equals 1, y equals 0, or y equals 1, x equals 0. And so in fact, no, let's throw this one away. Let's just see where we can get to with this information. So what we've got is that, and then we want to know what can we say about z. Well, if x is 1, then we know y is 0. So let's just we just want to run through our cases. So if x equals 1, y equals 0, and then just returning to this, we know that we must have this thing being true. And so in that case, z equals 0. So that's the one case. And then in the other case, if x equals 0, y equals 1, and in that case, we don't need y plus z to be equal to 0. So in that case, z could be anything. And so we can't conclude we can't conclude that z is definitely even or odd. I'll give more examples of that kind of method in the example video. I'm not sure I did it justice there. You'll see how useful it is. I gave a very hard example there, but it is definitely something to get used to and get acquainted with, because it just saves a lot of time. And then the last topic, the last sort of trick, there's questions where they ask something like, what is the probability that n plus 1, n plus 2 is divisible by 5? And so effectively, these questions can be very easy if you know the trick. This is 3 consecutive integers. What do you need for it to be divisible by 5? We need at least one of them to be divisible by 5. What's the chance that one, in a list of 5 consecutive integers, one of them will definitely be divisible by 5? So what's the chance in a list of 3 consecutive integers? Well, it's literally just going to be 3 over 5. And so you just sort of take the number of integers in a row and divide that by the number you're asking about. That's if it's prime. If they ask you something non-prime, so n plus 1, n plus 2, divisible by 8, that's immediately much harder. So this first trick, just remember that, memorize that for if you're asked about dividing by a prime, immediately get the answer. Nice GMAT question in 10 seconds. This type, much, much harder. And so if it's not prime, you have to sort of consider 2 cases. First case, so they probably wouldn't give anything harder than something like 8. So how do we get it divisible by 8? Well, first case, n is even, in which case n plus 2 is even, and we have 2 consecutive even integers. So in other words, one of them must be a multiple of 2 and one of them must be a multiple of 4. And so in this case, we must have one having a factor of 2 and one having a factor of 2 squared, in which case it will be divisible by 8. So, and how often does that happen? Well, n is even half the time. And then what's the other case? Well, the other case is where the n is odd, in which case only n plus 1 is even. And if that's the only even number, what do we need it to be? Well, we need to have a factor of, we need it to be divisible by 8. And what's the chance of that happening? Well, it's literally just the chance of one number picked at random being divisible by 8. And that's just going to be, well, as in one even number being divisible by 8. So that's 1 in 4. And so, but it's half, this happens half the time, and it's a 1 in 4 chance. So in other words, that's an additional 1/8. And so the answer would be 5/8. Hard question there. You'll see more in the example video, but quite a few rules there. So if you weren't familiar with any of them, go back through it, make sure you know all of these, and then sort of solidify it in the examples question coming up next.